We're looking here at some composite functions where we have the terms fog and goff, and we need to remember, as I've written here, that fog is f of g of x and goff is g of f of x. Let's have a quick think about the theory. What that means, if I'm dealing with fog, that means with f of g of x. That means first of all I have to do what's in the brackets, so I need to work out g of x and then f of x. So if I'm considering this machine style scenario, what happens is I have an input which goes into my g of x machine, and whatever comes out of that has to be able to go into my f of x machine, and then I get an output. So what that means, remembering our danger functions, if my f of x has a square root, a 1 over something, or a log of something, then it's possible that whatever comes out of g of x might not be able to go into f of x. For example, if I get a negative number here and I need to put it into f of x and I've got a square root, then that can't go. So what that means is that not all composite functions are defined across an entire domain, because we need to make sure what goes into f of x, or to be more precise, we need to make sure our domain for f of x is contained within what comes out of g of x or my range. So therefore we have a rule that says my range of g of x must be included in my possible domains, so it must be a subset of or equal to my domain of f of x. And that's my rule for how I make composite function goff work. Now let's have a look at the example. So first we're asked, what is f of g of x? So let's start that going. F of g of x will be f of 3x squared, because that's g of x. So now I'm going to substitute 3x squared wherever I see x in my f of x, which is 2 times 3x squared minus 1, which equals 6x squared minus 1. And there is no restriction on my domain here, because any number that goes into g of x will be able to come out. So x is an element of real numbers. However, when we think about the range here, we need to remember this is a parabola. So let's have a think about what a parabola looks like. So here's my thinking bubble. Here are my axes. And 6x squared minus 1, that's an right way up parabola, a smiley face parabola, that's been dilated 6 times this way and has been moved down by 1. So it's going to have a turning point at 0 and negative 1, and it's going to look something like that, which means that its range doesn't go below negative 1 but touches negative 1. So I can say that my range, or my y values, let's write range, and let's actually write domain here, because that's what the question asks for, domain and range. So let's answer in time. The domain is real numbers, and the range is from negative 1 inclusive to infinity. And there I'm using my brackets to describe the domain and range. So that's part A. Now let's have a look at part B. So this is asking us the different order, so things going the other way. And you'll find that our domain and range might be different. So for g of f of x, I will do f of x first. So my number will come into f of x, or the f of x machine, if you will. Then to the g of x machine, and then it'll come out. Now the good thing is we don't have any of those danger functions, the square root or the reciprocal or the log function, so we know our domains aren't going to be badly affected here. Let's work out what goff is, or what g of f of x is. and that will be g of f of x is 2x minus 1. And now if I put that into here, wherever I see x, I'm going to write 2x minus 1. So it'll be 3 outside of 2x minus 1 all squared. Now you need to be able to expand these pretty quickly. Remember, you can always double the brackets, but when time is of an essence, I would want you to know that that'll be 4x squared minus 4x plus 1. And we can probably leave it actually just as good like this as any other way. But if you needed to expand, you'd end up with 12x squared minus 12x plus 3. But this is a great way to write it because it's easier to sketch this way. And when you sketch this, you can see that we have, again, a parabola as given by the higher power of x. So it's going to look something like this. We've got a parabola. We have some dilation in this direction, so it's going to be a skinny parabola. We have a translation across here. So my translation, 2x minus 1, my translation is actually going to be half a point across. And we notice we don't have anything plus or minus out here. So there's a plus 0, if you will, which means it hasn't been translated up or down. So what we can do now is realize that our parabola for this part is going to look something like this. It touches the x-axis and it doesn't go below it. So therefore, for this function, and I'm going to make that function, I'm going to write it as this, because that's actually the best mathematical way to write it. So g of f of x equals 3 2x minus 1 squared, where my domain, again, are real numbers, and my range is from 0, including 0, because it touches the axis, up to infinity. And now I've answered the question on composite functions, considering the domain and range and any pitfalls which we might have had, but fortunately didn't have in this question.
If you found this video helpful, please subscribe or like. Thanks.